I have an image here. Now imagine that this is a frame from a certain storyline. What do you think the next scene should be? Of course, there might be many possible outcomes. Some transitions might have a small span, while others have a larger span. What you are seeing now are some results of automatically generating the next scene based on the previous frame. Notice that there is one word in my description that is very important. It's the word automatic. This means you don't need to conceive what the next scene should be. It will automatically generate it for you. To achieve this effect, we will use a LoRA. We have previously discussed this LoRA called Next Scene. When we talked about it before, it was the first version. Now, we have already upgraded to the second version. What kind of improvements does the second version bring? Let's take a look. First, it was trained using a higher quality dataset, which significantly improves the generation results. Additionally, the prompts have been fine-tuned, allowing them to better guide the model to generate images. Third, a bug was fixed. When using the previous version, we noticed that black borders would appear above and below the generated image. In this current version, this issue has been resolved. Finally, there is an overall enhancement, including smoother transitions and better cinematic fluidity. Here are some basic examples. Also, there is a workflow available here. If you are interested, you can download it and import it directly into your ComfyUI to use it. However, you need to be aware that simply using this LoRA alone cannot achieve the goal of automatic generation. So, how should you do it? You can look at the workflow that I have rebuilt for everyone. This workflow has also been constructed on Running Hub. You can access this platform through Running Hub in the ComfyUI domain. Running Hub is an excellent online workbench. This is because as soon as new technologies and new extensions appear, it follows up immediately. You can register for Running Hub using the invitation link in my video description. By doing this, you can receive 1,000 free points. Furthermore, you will receive an additional 100 points simply by logging into Running Hub daily. This way, you can try out your own workflows. Alright, next, let's take a look at the workflow I built for automatically generating the next scene. This workflow can generally be divided into two parts, upper and lower. The lower part is essentially a standard QW image edit workflow. So, note that I am using Edit Plus here, specifically version 2509. We also added an acceleration LoRA using Lightning, which is the 4-step acceleration LoRA. Also, please note here that this is the LoRA we use for the next scene, called Next Scene. Pay attention to its weight. It is recommended to be between 0.7 and 0.8. I am using 0.8 here. Next, we load an original image. This is the picture we just saw. This image is very simple, but it has a strong sense of storytelling. This here is our visual encoder, which uses Qwen 2.5 VL, and this is a Qwen image VAE. Below this, you need to pay attention to the prompt. According to its standard writing method, the prompt needs to start with Next Scene. But you must note that what you see here is not the actual prompt that I will be using. Because if you look closely at this prompt, it is generated directly from the previous process. This is what automation signifies. The negative prompt is empty. The resolution of the generated image is kept consistent with the original image. In the upper part of the workflow, we use a model that we have discussed before, the Qwen3VL4B. I will use a set of prompt engineering instructions to tell it how to generate the next scene. This content is relatively complex. You will find that it generates roughly 4 parts. The first part is the analysis of the current scene. The second is the method I will use to generate the next scene, which is my thinking process. The third part is the basic description of the next scene. The fourth is the prompt for the next scene. Of course, you'll notice that I don't need all of these parts. Which one do I need? I currently need the third part. Some might ask why not the final prompt. I will explain that in detail later. So I extract the third part now. How do I extract it? We use a node called prompt line. You can specify which index to start from and how many lines to extract. A point you need to be careful about is that there is a blank line here, and this blank line must also appear as an element. Therefore, when I want to extract this section, this becomes index 0, this is 2. So it is 4. Pay attention to this counting method. Then I have a descriptive text here called Next Scene Description. So I must replace this text. I use a node called string replace for this. This node is provided officially by ComfyUI. Now, I replace this piece of text with nothing empty. That results in the effect you are now seeing. Then we connect this prompt to this location. This is the final generated output that you see. Of course, the results vary each time. Sometimes the span is quite large, and sometimes it is relatively smaller. Sometimes there are pleasant surprises, and sometimes there are frights. Let's test a couple. Let's run it. Take a look. The transition span generated here is quite large, but we have generally ensured the consistency of the character and the environment. Let's run one more. Now look, this span is even larger. You could consider the next scene of this image is her going to the mirror and applying makeup. You can see that this automatic capability is quite powerful. Of course, what I have explained to you so far are standardized operations. The most crucial part is actually how this is written. How is this written? Of course, you cannot just write randomly or just guess it yourself. Here, we need to look at what its official documentation roughly explains about how the next scene is derived. If we have the current frame and we want to know what the next scene should be like, we follow a basic principle, maintaining graphical coherence while introducing an organic transition. How does this transition occur? It happens through several methods. The first method is camera movement. The second is the evolution of framing. The third is environmental change. These are roughly the main aspects. You can use one of these or combine several of them to deduce what the next scene should be. Once we have grasped these basic principles, we can start writing the prompt engineering instructions. Next, I will briefly explain how this prompt engineering is written. First is the role definition. You are an experienced film director or a visual storytelling expert. What is your task? It is to analyze a static frame from a movie and then guess what the next frame should look like. Then we write the principles right here. How do you deduce the next frame? You can do it through the following 4 aspects: changing the perspective, making environmental changes, performing some basic camera movements, and then imagining what the next frame will be. To ensure the completeness of its thinking process, we have divided it into 5 stages. The first stage is analyzing the current frame. The second is conceiving the next frame. In conceiving the next frame, I have a special requirement here. That is, to ensure it has a relatively large change compared to the current frame. Therefore, I require that the overall scene should have a significant alteration. As we demonstrated earlier in the workflow, you notice that the transition between this frame and the next is quite substantial. If you do not like this effect, you can simply remove this sentence. Moving on. Next, we need to select a cinematic technique. How do you transition into it? Here, you choose one or several techniques. The fourth stage is where we write about the transition of the next scene, specifically how to change from the current frame to the next frame. Finally, a complete prompt is generated to make the generation more detailed. I provided it with 3 examples to show it how to generate. Below that, I tell it what the output structure should be. The output consists of 4 parts. The first is the description of the current scene. The second is the conception of the next scene. Below that is the description of the next scene, and finally, the complete prompt. However, based on my testing, the best result is not the final complete prompt, but rather the third part. Now, let's go back and I will explain to everyone why this is the case. You will find that the prompt it provides is actually not a prompt in the traditional sense. It essentially describes how to transition from the current shot to the next shot, and then describes the next shot. You will see that every example follows this pattern. That is why we use the third output part. If you look back now at this section in our workflow, this is our original output of 4 items. So this is quite interesting. By embedding the large language model, you find that automation becomes relatively simple. I just mentioned to you the sentence I added here. If you feel that the span is too large, you can remove it. If you remove it, the span won't be as large. You need to consider your actual requirements. Let me run a test for you. Take a look. In this case, the scene transition will not be as large as before. Each approach has its own advantages and disadvantages. You must decide based on your own circumstances whether or not to include that sentence. These are the basic techniques for generating prompts that I wanted to share. Of course, I also provided you with 2 versions of this prompt engineering setup. One is the English version, which I just demonstrated, and the other is the Chinese version. Naturally, what I am providing you with is primarily a conceptive framework. You can use this concept to fine-tune your prompt engineering to achieve even better generation results. Due to the time constraints I had, the prompt engineering I provided should only be used as a reference. I hope this helps you in your future work. Alright, that is all for today. Follow me to become someone who understands AI.